fill it all the way up to that 1 liter line, you would have a concentration of 1 molar. What are our units? We could either use moles per liter, that's fine, or our symbol molarity, or capital M, means moles per liter. It's how much of a solute, remember that's the little one, is in a given amount of solvent or solution. And several ways we do this in chemistry. There's actually quite a few ways. One of them is molarity. And the symbol for molarity is a capital M. It must be a capital. Okay, and I like to make it really big and squared off, okay? And you'll see why in a minute. There's another one that's a lowercase m. So it is defined as the number of moles of solute, remember that's the small one, divided by liters of solution. So how you make a solution is using a volumetric flask, and these things have a certain volume. Let's say this one is 1 liter. And so what you would do is add a little bit of water to the flask, volumetric flask, and then if you added 1 mole of a substance, let's say you put in 1 mole of some solute, and you dissolved it, fill it all the way up to that 1 liter line, you would have a concentration of 1 molar. So that would be 1 mole in 1 liter of solution, and we would say that is 1 molar. So you may see those in the lab. All right, let's work a problem. This is more like what you're going to need to do probably for your class. So I've got the definition there for you. The first thing we've got to do is figure out the solvent and the solute. So the solute looks like it is sodium hydroxide. And so here's my definition of molarity. So I need to get the moles of solute first. And so 27 grams of sodium hydroxide, 1 mole of that is 40 grams. And so we've got 0.68 moles of sodium hydroxide. Okay, then we've got our molarity. We need our liters of solution, which we have. So 0.68 moles divided by, well, there's our volume of solution. So we'll divide by 1.5 liters. And our answer is going to be 0.45. Now, what are our units? We could either use moles per liter, that's fine, or our symbol molarity, or capital M, means moles per liter. So either way, that is concentration in molarity. Let's look at a similar problem, but this time we've got milliliters. Well, I had that same quantity in our last problem, so that's 0.68 moles of sodium hydroxide. So our molarity is going to be 0.68 moles of sodium hydroxide, but this time we don't have liters of solution, we have milliliters. No problem, convert that to liters, and so that's divided by 1,000, so we have 0.25 liters. So our concentration in molarity this time is 2.7 molar. Notice this is a more concentrated solution than we had in our last example. This one was 0.45 because we had over a liter of solution and the same quantity of solute. So the second example, I used the same quantity of sodium hydroxide, but less water, so a less volume of solution, more concentrated. Let's look at another example of something you may need to do. Well, we've got our, this time we know the concentration of solution, we know the volume, but we're looking for moles of sodium hydroxide. So I want to show you a little trick that I like to use. I'm going to start with the given volume. Now, I don't want the volume in milliliters, I want it in liters. That's the amount of solution. Now, I know the concentration is 0.55 moles per 1 liter, right? I don't have 1 liter, I have 1/4 of a liter. So if I multiply that, look what happens to my units. The liters cancel, and I get 0.14 moles of NaOH. Okay, so volume, moles, and concentration are related by this formula. And you'll need to be pretty adequate at dealing with those types of calculations for lots of future chemistry problems in your class.